All right, we're looking at the handout for centers of triangles. Centers of triangles. This extra handout, this is going to be the cheat sheet that you use on the test. And hopefully this will be a way to clear up some trouble that might have happened when we talked about the big general overview of the centers of triangles. This will hopefully be a little bit more condensed, a little bit more simplified version of that information, and be hopefully more relevant to you when you work on the practice problems that go with this. All right, so the first one we're looking at here is the circumcenter. Our circumcenter is created by perpendicular bisectors. Let's see if I can spell this. Perpendicular bisectors. Perpendicular bisectors, remember what that means. Okay, perpendicular means it makes right angles with the side of the triangle, and bisect means that it cuts the side of the triangle in half. Okay, so that makes it to where BY and CY are the same length. CZ and AZ are the same length. Okay, we're not necessarily super concerned about the workings of that right now. We already know what bisect means. What we are more concerned about is how this thing all works together. Okay, the important facts here is that first, the circumcenter is equidistant from each vertex of the triangle. All right? What that means is that these things that I'm about to highlight are all the same length. BM, AM, and CM are all the same length. Okay? As we talked about in the previous video, that's because when you draw a circle that touches all three corners of the triangle, that's the center of that circle. So all of those lines represent a radius. They all represent the same exact length. What that means for us is it sets up some equations. Okay? And it's very simple equations. AM equals BM and equals CM. Okay? It is equal distance. It is the same distance from every corner of the triangle. Okay? So from all the corners A, B, and C to that point, that circumcenter, it is the same distance every time. Go on now to the end center. The end center is created by angle bisectors. Now we already talked about that word bisect means cut in half, but this time instead of the sides of the triangle getting cut in half, it's the angles that are getting cut in half. Okay, you can see it right up here. You can see that angle A got cut into two equal parts because they both have one arc right down here. You can see angle C got cut into two equal parts because both of those small angles right here and right here, they both have three arcs, so they're congruent to each other, okay? That means they got bisected. What that means for us is it notes where the end center is. The end center is equidistant, so same distance, from each side of the triangle. All right, what that means for us is when we look at this picture, it means that this point in the middle, this end center, is the same distance right here, and right here, and right here. All of those are the same distance right there. So that gives us the equations that look like this. Very similar to that last one. It's a bunch of stuff that's equal. It gives us that XM is equal to YM, which is equal to ZM. All right? When you're dealing with angle bisectors, when you're dealing with the end center, all of those distances are the ones that are the same. The next one we're looking at, excuse me. Next one we're looking at, I actually want to skip to the end and look at the orthocenter. All right, the orthocenter is created by altitudes. In parentheses, altitude, it's the same thing as the height of a triangle. We'll go ahead and say heights. Okay, remember back to middle school math. When you learned about the height of a triangle, that wasn't just the same as taking a side length like that. You couldn't just do that. You had to take the distance from the corner and drop it straight down and make a right angle right there. You couldn't just take this side length because that was longer, okay? Your height was the distance it made when you dropped it straight down and you made a right angle like this picture, like what we have in the picture right here. So what that tells us is if you did that for all three of them, you meet in this point right here called the orthocenter. Okay? We're keeping track of what an altitude is. An altitude is created by a vertex connected to the opposite side so that it's perpendicular. Okay, you're connecting the corner to the opposite side so that it makes a right angle. Right angles. That's the name of the game with perpendicular. Right angles. All right. Now, this last one, the centroid, is the most complicated one, and we've got several practice problems that are dedicated to it. Okay. This is the one, because it's the most complicated, it's also the one that's most likely to come up on the DCA or your final exam, so be on the lookout for that. All right. This one right here. It is created by medians. Now, a median, that's the important fact down here. A median is what happens when you have a vertex connected to the midpoint of the opposite side. So on the orthocenter, we took the vertex and connected it straight to the opposite side, the shortest distance to make a perpendicular, to make a right angle. On this one, we're connecting the vertex to the midpoint. So when we connect B to Z, it makes it to where AC and CZ, AZ and CZ are the same length. Same thing right here. These two are the same length, and those two are the same length. Now, we're not super concerned about that because if you just look at the diagram, you already know that's true because it's got all those handy little hash marks right there and right there that tell you if it's going to be congruent or not. Okay, so we're not super concerned about that part. What we are concerned about, though, is the segment lengths that are inside of this picture. On the inside of this picture, the way this works out with a centroid is that if we are looking at this whole entire median going across right there, if we're looking all the way at AY, if you take this chunk of it, this longer chunk, AM, from A to M, that is 2/3 of the length of the whole entire thing. This smaller chunk right here, MY, is 1/3 of the entire length. And that sets up some pretty complicated little equations. Now, I say they're complicated, they're really not. It just looks like it because it's got some fractions in it, okay? It sets up like this. AM, the distance from the corner to the centroid, is 2/3 of the length all the way across from the corner to the midpoint. Okay, in exactly the same way, the point going from the midpoint to the centroid, MY, is 1/3 of the full thing, AY. Now, if I draw this off to the side, y'all don't have to write this part down, but I do want to show you this. Okay, if you have 2/3 of something, or if you have 1/3 of something, and you multiply that times 2, well, that would be 2/3, right? Okay, you would now have 2/3 of that. What that fact does for us is it sets up this equation right here that's maybe a little bit easier to deal with. If you're dealing with your two pieces, AM and MY, you can tell, because of these two equations that we already wrote down, you could also say that AM is twice as much as MY. And MY is half as much as AM. Now I'm going to tell you that these two on the side over here, these two right here, are going to be a little bit easier to use a lot of times than trying to multiply something times 2/3. Okay? So if you already have one of the smaller pieces, definitely use these. Okay? You're not going to be able to every time, but if you can, if you already have one of the small pieces given to you, use these equations on the right side. Now, this is another one of those things that looks a lot more complicated than it is, especially on the problems where it just gives you numbers. Okay, a lot of times it'll just give you numbers for what those chunks are. It'll give you a number for what AM is, it'll give you a number for what MY is, and all you have to do is relate them using these equations. So it looks a lot more complicated than it actually is. We can do some example problems. There are plenty of examples that you'll have on paper and on campus both. All right? Now this cheat sheet you're going to be allowed to use on the Topic 5 test. Do not lose track of it. Do not destroy it between now and then. Okay? This is the only thing you're going to be allowed to use. You can use this and you can write more stuff on the back, but that's going to be it. Okay? Anything else is not going to be allowed. So keep track of this thing and don't lose your minds between now and the test. That's all we got. Y'all have a good day.